Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, please do subscribe to my channel. So in my previous video, I was actually explaining the 4th chapter of 9th standard science subject, that is structure of the atom. So in this particular video, I'll be teaching the exercise questions which are actually left out in this particular chapter. So coming to the first question in this particular exercises. So in that first question, they have asked to differentiate between the properties of electrons, protons and neutrons. So what are all the properties of electrons, protons and neutrons? So when we look into electrons, electrons are basically negatively charged particles. If you consider protons are positively charged, and when you consider neutrons doesn't have any kind of charge on it, either positive or negative. So that's why neutrons are neutral charged, protons are positively charged, electrons are negatively charged. When you actually compare the mass of electron, proton and neutron is having more mass compared to all these three subatomic particles. So neutron comparatively have more mass. So proton also have comparatively equal mass as neutron, but when you exactly look into the numbers, proton have little bit lesser mass than neutron. So comparatively equal to neutron mass, and the mass of proton is 1.67 into 10 power minus 27 kg. Similarly, if you consider mass of electron is 9.31 into 10 power minus 31 kg. So this is the mass of electron, this is mass of proton, and neutron mass is slightly greater than this 1.67 into 10 power minus 27 kg, which is almost comparable with the mass of proton. So coming to the other property, protons and neutrons both exist inside nucleus. So in an atom, if you consider nucleus, which is at the center of the atom, in that nucleus both these protons and neutrons will be there. But electrons, they will be not there inside nucleus, but electrons will be revolving around nucleus. That is, electrons will be revolving around nucleus, but they will not be there inside nucleus. So electrons will be revolving around nucleus. So if you refer my previous videos, you can still identify more properties related to electrons, protons and neutrons. So one of the important property of electrons, protons and neutrons is that they are all subatomic particles. So what do you mean by subatomic particles? Particles which are there inside an atom. So all these are subatomic particles which are there inside atom. Protons and neutrons will be there inside nucleus. Electrons will be revolving around the nucleus. And electrons are negatively charged and protons are positively charged, and neutrons don't have any kind of charge. And mass of electron is 9.31 into 10 power minus 31 kg. When you compare mass of electron with proton and neutron, it is very less. And if you consider mass of proton, 1.67 into 10 power minus 27 kg is the mass of proton, and mass of neutron is also comparable with the mass of proton, or mass of neutron is slightly more than the mass of proton. So coming to the second question in this particular exercise, there they have asked for limitations of J.J. Thomson's model. So what are all the limitations of J.J. Thomson model? So one of the limitation of J.J. Thomson's model is that this particular model doesn't explain the stability of atom. So stability of an atom is not explained in this particular J.J. Thomson's model, and also this model doesn't explain how positive charge hold these particular electrons. How positive charge hold electrons is not explained in this particular model. Coming to the next limitation of J.J. Thomson's model, there is no proper explanation of nucleus, and this particular model doesn't discuss about protons as well. So protons and nucleus are not discussed in this particular J.J. Thomson's model, and also it fails to explain Rutherford's scattering experiment. It fails to explain Rutherford's scattering experiment. So we all know in Rutherford scattering experiment, alpha particles were actually passed through the gold foil. According to J.J. Thomson's model, this particular atom is a positive sphere in which electrons are embedded, where charge of electrons and the charge of the positive sphere of the atom will be balanced. This particular alpha particles which are positively charged should be deflected, like all the alpha particles should be deflected by the atoms present in gold foil. But surprisingly, most of the alpha particles will pass through the gold foil, and only little alpha particles will deviate with certain angle, and 1 in 12,000 alpha particle got reflected back. So this particular phenomena couldn't be explained by J.J. Thomson's model. So that means here fundamentally, where in this particular model it was considered that this particular atom is made up of positive sphere and electrons are embedded in that positively charged sphere of that particular atom. The observations which are made by Rutherford scattering experiment was not explained by J.J. Thomson's model. So this is also one of the limitation of J.J. Thomson's model. So if you have any more limitations for J.J. Thomson's model, that also you can add for this question. Coming to the third question in this particular exercise, here they have asked the limitations of Rutherford's model. So here also one of the major limitation of Rutherford's model is stability of atom is not explained. Why stability of atom is not explained? Because in Rutherford's atomic model, Rutherford discussed that positively charged nucleus will be there in the center of an atom, and around this particular nucleus electrons will be revolving in a circular orbit. So if you consider this as an atom, all these electrons will be revolving in a circular orbit around the nucleus present in that particular atom. So any particle which actually moves in a circular path will accelerate, because to maintain the angular velocity they actually undergo acceleration. And when a charged particle accelerates, because here electron is negatively charged, so whenever a negatively charged particle accelerates, at that time it has to radiate energy, and when it radiates energy it loses its energy, and when electron loses its energy, in the place of following circular path it should follow a spiral path, because the radius of its orbit in which it is circulating will go on reducing, and finally electron follow a spiral path, and finally electron should fall inside nucleus. If that happens, then stability of atom will be not there. So but we can see all the matters which we are seeing around us are much more stable. So stability of atom is not explained in this particular Rutherford's model. So how the electrons are arranged in the circular path? Because you have multiple electrons present in the higher elements. How all these electrons are following circular path? Do all the electrons follow the same circular path or different circular path, or in what manner electrons are moving in a circular path? So this particular arrangement of electrons in that particular circular path, in that particular circular orbit, is not explained in Rutherford's atomic model. So these two are the major limitations of Rutherford's model. Even the energy levels of electrons are not explained in this particular Rutherford's model. So still there are so many other limitations as well. You can also search for other limitations of Rutherford's atomic model. Coming to the fourth question, here you should actually explain the Bohr model of an atom. So what is Bohr model of an atom? Bohr came up with two postulates to explain the limitations of Rutherford's atomic model. So the first postulate of this particular atomic model is that electrons revolve in a discrete orbit, only in an allowed discrete orbit. So there are discrete orbits present in an atom. So I have explained about discrete orbits in my previous video. So in an atom, if this is a nucleus, then there will be orbits which will be around this particular nucleus, where the first orbit is n is equal to 1 energy level, second orbit is n is equal to 2 energy level, third orbit is actually n is equal to 3 level, and these particular orbits are also named as K shell, L shell, M shell, like that it goes on. So all these things I have explained in my previous videos. You can refer my previous videos for Bohr model of an atom. So in brief, electrons revolve in a allowed discrete orbit inside an atom. Coming to the second postulate of Bohr model of an atom, here he explains that whenever electrons are moving in the allowed discrete orbit, so whichever discrete orbit is allowed for a particular electron, whenever it is moving in that orbit, other than any other orbits, it is only moving in its allowed orbit, at that time that particular electron will not radiate any kind of energy. So electrons revolving in a discrete orbit will not radiate any kind of energy. So when it doesn't radiate any energy, at that time it doesn't loses its energy, and hence it will not collapse inside nucleus. So thereby stability of atom is actually explained in this particular model of an atom. So here two main postulates you have to explain. One is electrons revolve in a discrete allowed orbits, and also when electrons revolve in this particular discrete orbit will not radiate any kind of energy. And all the discrete orbits are given with certain energy level, where first discrete orbit is known as n is equal to 1 energy level, or that particular orbit is known as K shell. The second orbit is L shell, where the energy level of L shell is n is equal to 2, and coming to the third orbit is known as M shell, and the energy level of M shell is n is equal to 3, and it goes on like that for higher elements. So first you should explain this particular postulates 1 and 2, and then you can explain the energy levels which are present in the Bohr's atomic model. So thereby you can explain the Bohr model of an atom for this particular fourth question. Coming to the fifth question, here you have to explain all the models which are actually discussed in this particular chapter. So you can refer my previous video where I have explained J.J. Thomson's atomic model, and I have also explained Rutherford's atomic model, and I have also explained the Bohr model of an atom. So in Rutherford's atomic model and J.J. Thomson's atomic model, stability of atom was not explained. In Bohr's model, he came up with an idea of discrete orbits and hence explained the stability of an atom. So in J.J. Thomson's model, electrons were embedded in a positive sphere. In Rutherford's model, positively charged nucleus will be there in the center of an atom, and there will be a lot of empty space present in an atom where electrons will be revolving in a circular orbit around that particular nucleus. Coming to the Bohr's model of an atom, here he explained that electrons do not circulate in any allowed circular path. It will revolve around nucleus only in an allowed discrete orbit, and that particular discrete orbit will be assigned with a particular energy level, where the first discrete orbit is assigned with n is equal to 1 energy level, the second orbit is n is equal to 2 energy level, and the third orbit is n is equal to 3 energy level, and it goes on like that. And those orbits are named as K, L, M and N shells. So this is the Bohr's atomic model. So like this, all three models I have explained in my previous videos. You can refer those videos and you can actually write answer for this particular fifth question. Coming to the sixth question in this particular exercise, here they have asked the rules for electronic configuration for first 18 elements. First rule states that in any orbit, based on the energy level of that particular orbit, electrons, only 2n square number of electrons are allowed in that particular orbit. So this is the maximum number of electrons which are actually allowed in a particular orbit. So if you are considering n is equal to 2 energy level for an orbit, so if you are considering second orbit, then the energy level of second orbit is n is equal to 2. And if you substitute this 2 in this particular formula, it will be 2 into 2 whole square. So 2 square is 4, 2 into 4 will be 8. So that is 8 electrons are allowed, like maximum 8 electrons are allowed in this particular n is equal to 2 energy level, that is in the second orbit. So like this, even for higher orbits, whatever the energy level will be there, that you take as n and substitute in this particular formula. So you'll get maximum number of electrons. Only those maximum number of electrons are allowed in that particular orbit. That is 2n square maximum number of electrons are allowed in a particular orbit. So this is the first rule of electronic configuration. Coming to the second rule of electronic configuration. So if you are considering the outermost orbit of an element for the first 18 elements, then that particular outermost orbit can only contain 8 electrons in it. That is the maximum number of electrons which can be there in the final orbit is 8 or less than 8 electrons. So for the first 18 elements present in the periodic table, only maximum 8 electrons are allowed in the outermost orbit, that is in the valence orbit of that particular element. So maximum 8 electrons are actually allowed in the valence shell or the outermost shell of an element. So this particular rule is actually applied for the first 18 elements of the periodic table. Coming to the third rule of electronic configuration, any electrons will first occupy the innermost orbit and then they go on occupying the later orbits. That is, the innermost orbits of an atom is filled and then they go on filling up the higher orbits. So this is the third rule of electronic configuration. So all these three rules you can write and explain in your own words. So coming to the seventh question in this particular exercise, here they have actually asked to define valency by taking the example of silicon and oxygen. So if you consider silicon as your example, in silicon you have 4 valence electrons. So as I actually discussed the rules of electronic configuration of first 18 elements, here I have discussed that the valence shell, the outermost valence shell of an atom, where only 8 electrons are allowed in the outermost shell of an atom. So according to this particular second rule of electronic configuration, here we can see that valence electrons present in silicon is 4. So because 4 valence electrons are present in this particular silicon, in the outermost shell of the silicon atom, here maximum electrons are 8 and the amount of electrons which are there in the outermost orbit of this particular silicon atom is 4. So 8 minus 4 is 4. So that is 4 will be the valency of this particular silicon. That means this silicon can accept 4 more electrons to have a stable outermost orbit. That is, this particular silicon to become stable, it has 4 more valency. So that's why valency is known as combining capacity of an atom, because how much more electrons that particular atom can accommodate is actually the valency of that particular atom. Whereas coming to the oxygen atom has 6 valence electrons. So if it has 6 valence electrons means maximum allowed electrons in the outermost orbit. This particular 6 valence electrons are the electrons present in the outermost orbit of an atom. So outermost orbit of an oxygen atom contains 6 valence electrons. Because it has 6 valence electrons, where maximum 8 electrons can be present in the outermost shell of first 18 elements. So 8 minus 6 will be 2. So 2 will be the valency of this particular oxygen, and because 2 is the valency of oxygen, oxygen can accept 2 more electrons to become stable. That is, in order for oxygen to become stable, 2 more electrons is required. In order for silicon to become stable, 4 more electrons is required, or this particular silicon can donate 4 electrons or accept 4 electrons, because valence electrons and valency are equal for silicon. But in oxygen, it has 6 electrons in its outermost orbit. So donating 6 electrons is difficult compared to accepting 2 electrons. So accepting 2 electrons is easy for oxygen atom. Hence, valency of oxygen atom is 2. That is, oxygen can accept 2 more electrons, where valency of silicon is 4, where silicon can accept 4 more electrons. This is all there in this particular video. Remaining questions which are there in this particular exercise I will be discussing in the next video. So if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then please do subscribe to my channel and stay tuned with my channel.